afternoon, students. I welcome all of you to yet another lecture of the course on simulation of business systems. And today we are going to cover the topic terminologies and like approaches. It's some additional terminologies and the stochastic simulation that we are talking about. What are the type of stochastic simulations that we are going to cover as part of the course? Also going to be looked into it. So this section's major learning agenda are four. The first one is we talk about the analytic, actually not the analytics, it is analytic versus the numeric methods. Okay. So, let us see how the analytic method and numeric method compares, and most of the type of variables, these are the variables to be used in simulation. Okay. And then some on the simulation like methods, and we will look into Monte Carlo simulation. So, today's topics are mostly related to slightly advanced concepts, and we will also do an example of Monte Carlo simulation, so that you can understand what is Monte Carlo simulation. So, let us get into the first topic today called as analytic versus numeric simulations, or analytic versus numeric approach. And by definition, the analytic mode, okay. So, let us write it this way: analytic mode or approach, okay, uses the traditional. So, the analytical mode or approach uses the traditional mathematical and statistical techniques, Okay, they use the analytical and mathematical techniques to obtain exact information about the system that is being modeled, or what we call as that is being simulated. Okay. So, the most important thing is this approach, this mode utilizes the traditional mathematical and statistical approaches. Okay. We use traditional mathematical and statistical approaches or techniques, and why do we use that? So that we can get exact information about the system that is being modeled. So, the focus here is on exact information. Okay. We want the exact value, okay, and usually works when the system is simple. Okay. So, this is the analytic approach. The numeric approach, whereas the numeric approach, or we can call it as the method, the numeric method, okay, replaces these complex mathematical and statistical operations, with a large number of simple computations. Okay. So, what do we do is we eliminate the complex mathematical and statistical operations, or we eliminate those equations, and then we replace them with a large number. This is the important word, large number of simple computations. Okay. And focus is on obtaining an estimate of the specific characteristic of interest. Okay. So, the idea here is that our main aim is to the focus is on obtaining an estimate. Okay. Unlike, so not focused on exact information. Okay. So, we do not look for the exact info, instead we want an estimate. An estimate is, in another way to think about it, as an approximation. Okay. You want to estimate the specific characteristic of an interest. Okay. Also, usually the only method to analyze complex system or systems. Okay. So, when the system is complex, when the system is complicated, then you would rather like to use the numeric method or the estimation method, where the aim is to obtain an estimate and not an exact information, unlike the mathematical and statistical technique. And the numerical approach replaces the complex mathematical and statistical operations or the equations. Okay. These operations can also be thought as the equations. Okay. So, here you replace the equations or the mathematical operations with a large number of simple computations. You use computers to do a set of simple computations to obtain this particular thing called as an estimate, okay, or an approximation. That is the numeric method. And when the systems are complex, when you are dealing with large complex systems, then you use a numeric approach instead of the analytical mode, which is more dependent on the traditional mathematical and computational approach. So, let us here look at an simple example. Okay. And this demonstrative example, we will first try to take a look into this example in the form of an analytic approach. Okay. So, the system is, the aim is to obtain the value of x for which the f of x will be at its maximum. Okay. That is what the max concept says, the maximum part. So, you are trying to find out that value of x, particular value of x, for which the f of x, the resulting function, will be at its maximum. What will be the value of this? So, the analytical method, the analytical approach method amounts to what? Amounts is find the first derivative, or what we call as f dash x. Okay. Then equate it to 0. Okay. Then solve for x to obtain the value of x. Okay. So, let us see how it is done. So, your f of x is equal to 3x minus 0.005 x square minus 500. So, the f dash x, the first derivative, equal to d by dx of 3x, this is your y, okay, 0.005 x square minus 500. Okay. So, the which will translate to this will become 3 minus this will be 0.005 times 2 times x, and this will be 0 because the constant derivative will be 0, which will be equal to 3 minus 0.01 x. Okay. Now, the thing is, you say f dash x, the first derivative you set to equal to 0, implies d by dx, dy by dx is set to 0, implies 3 minus 0.01 x should be equated to 0, which gives you what we call as 0.01 x is equal to 3, right, which implies x is equal to 3 divided by 0.01 or equal to 300. Okay. So, the analytical method tells that at x equal to 300, f of x will be at the maximum value. And what is this? It's an exclamation, sorry. Okay. So, what is this maximum value? What is this maximum value? That maximum value is obtained by f of x is equal to 3 times x will be 300 minus 0.005 times 300 square minus 500. If you solve this equation, then you will get the value of f of x, which will be the maximum. So, this is the what we call as the exact value that we were looking for. Okay. So, the main thing is that this equation represents a simple second degree equation. Think about a simple quadratic equation, right. So, now because of this you can apply mathematical methods. You can do that and then you get the result. So, let us say instead of this, okay, if the question was the equation was complicated, if the equation instead of this was something like this, f of x is equal to 3 times x to the power of 4 minus 0.005 times x to the power of 7 or something like this, minus 500, then it would not have been that easy like what we have done now. Okay. This would have been a complicated case. Then you might have resorted to something else. So, the same question or same problem that we are talking about, how can we actually solve this using the numerical method is what we are going to see in this slide. So, the same system, okay, the same equation 3x minus 0.005 x square minus 500, we are trying to solve this using the numerical method. So, the numerical approach, the numerical method or the numerical approach is roughly as follows. Okay. So, the rough approach is like this. First, okay, start with a value of x in a loop. Okay. Then using this x, find the value of f of x. Okay. So, you first start with the value of x in the loop, you take in a put it in a loop, a computer loop, a programming loop, and then in which you put a value of x, a particular value of x, and for that you find the value of f of x. Okay. Once you find the value of f of x, then the third one is increment the value of x to the next value, that is x1. Okay. You increment of the value of x to the next value, that is x1, right. Then 4, using the new x1, find the value of f of x1, right. So, you first use x, find the value of f of x, then increment the value of x to x1, then using that x1 find the value of f of x1. Then you compare. If f of x1, okay, is greater than f of x, okay, then x1 becomes the new best known solution, okay, and the values are updated. Then the fifth one is, continue the loop. You repeat this process until a result within an accuracy is obtained. Here you are not looking for the exact result. So, with a reasonable accuracy we can actually get this. So, let us take a look into what we call as this. Let us start with the loop where x, let us put it as x equal to 0. So, then at x equal to 0, f of x will be is equal to 3 times 0 minus 0.005 times 0 square minus 500, which will be equal to minus 500. So, at x equal to 0, f of x will be minus 500. Now, let us update x1 to be 100, okay, for the time being. So, the f of x1 is equal to 3 times 100 minus 0.005 times 100 square minus 500. Okay. So, we look into this, then that gives you what we call as, that is 300, and this is 100 square is 1000, multiply by this, this will give you 50, and this minus 500, which gives you minus 250. Okay. So, now if f of x1 is greater than f of x, implies if minus 250 is greater than minus 500. Is this correct? Yes, this is correct. Yes. Then x1 is the new best. Okay. Now, let us see what happened when we take the next x1. Okay. So, let us now increment x1 to, so now the f of x has become, so this is now x equal to 100, f of x is equal to minus 250. Now, x1 equal to 200. If that is the case, then what happens? Then f of x1 will be 3 times 200 minus 0.005 times 200 square minus 500, which is equal to 3 times 200 will be 600 minus 200 square times this will be minus 200, then minus 500, which will give you what you call as minus 100. Now, if you check this, if minus 100 is greater than minus 250. So, now you are comparing with the previous value. Okay. This 100 is being compared with what we call as the minus 250. Yes, this is true. Yes, true. The new best is x equal to 200 and f x is equal to minus 100. This is the new best. Now, let us take x1 is equal to 300. Then f of x1 will be 3 times 300 minus 0.05 times 300 square minus 500. So, that will be 900 minus 450 minus 500, which will be minus 50. So, now if you look into this value minus 50 is larger than minus 100. So, your new x will be equal to 300 and f of x will be minus 50. Okay. Now, do we stop here or do we continue? So, now we will take the next one, which we called as x 1 is equal to 400. Okay. And at x 1 equal to 400, we will get f of x 1 will be equal to 3 times 400 minus 0.005 times 400 square minus 500, which will give you 1200 minus 800 times 500. Now, this will give you minus 100. Now, you know that at x 1 equal to 400, the value has gone. So, now if minus 100 greater than minus 50, is this true? No, this is not true. So, then what happens is the new value. So, now we figure out that the best value of x, best value is somewhere between 300 and 400. Now, what you do is, now you do a loop between 300 and 400 and try to compute, do this again. So, you can see that there is a, this is what we call as the large number of computations. Okay. So, that is the reason why we end up doing a large number of computations to do this, and then now we repeat the same thing for 300 and 400 and we repeat this process. So, this approach is what we call as this approach is called numeric approach or numeric method. Okay. You are not really trying to find out the exact value, instead you are trying to find the estimate of this. So, this will look silly for such a simple problem, but as the problem becomes complicated, as the degrees of the equations becomes larger, then you have no other choice but to basically go with this method and then find the solution to the problem. Okay. With that, now let us get into the next major concept that we are going to see as part of today, which is called as the variables. Okay. And these variables are pertaining to, okay, here we are discussing only simulation variables. Okay. We are only focused on simulation variables. We are not talking about what we call as the mathematical or programming variables. We are not talking about mathematical and programming variables. Instead, we are talking about simulation variables or variables that are used as part of your simulation model. Okay. So, most of the simulations or most types of the simulations has the following variables. Okay. So, we will list the number of variables now here, and then we will see, or the major variables here, and we see what are the main ones. The first one is the what we call as the output variables, and we will see each one of these variables in detail in the following after we list all these variables. Then the one that we call it as the lagged output variables. I will explain to you what the lagged output variables are, and they are also important in the case of simulation. Then what we have is called the external variables. Okay, we use external variables. Then after that, what we have is the policy variables. I will also explain to you what a policy variable is all about. Okay, policy variables. Then we have what we call as random variables. Okay, whereas this is similar to the probability concept. Probability concept, but we will see this in detail. And then the last type of variable is what we call as the deterministic variables. Okay. So, these are the major variables. The first one is the output variable, second is the lagged output variable, third is the external variable, fourth is the policy variable, fifth is the random variables, and sixth is what we call as the deterministic variable. So, we will talk about these 6 variables which are quite common. Okay. All of these 6 are common to most simulation approaches. Okay. In one way or other, these 6 variables gets used in the simulation model or simulation approach that we do. Okay. Now, then let us see what are the main thing called as the output variables. Okay. So, the output variables pertaining when in the case of for simulation, in the case of simulation, the output variables, the most important thing is they provide intermediate or final results of the analysis. Okay. So, what analysis? That is the numeric analysis, numeric analysis of the system. What we are focusing here is the numerical analysis of the system. So, it gives you the intermediate, okay, in between or final results of the analysis, the numeric analysis of the system. Also popularly known as, okay, we call these variables popularly known as dependent or response variables. See, somebody says I am talking about the dependent variable or response variable. What they are talking about it is they are either talking about the output variables, and the output variables provide you an intermediary or a final result as part of the numeric analysis of the system. So, the same term, the dependent variable or the response variable that people use is also the same as that of an output variable. Okay. So, major examples of output variables okay, include, okay, let us consider a special case or specific case of a manufacturing system. We are talking about a manufacturing system. For that case, the specific variable, output variable, some of the variables included is, okay, number in the system, okay, which tells you how many parts are in the system. Okay. You are answering that question, number in the system, okay, most commonly known as number in system. So, it is an example of an output variable. Okay. Then number arrived. In a manufacturing system, it will be how many parts have arrived in the system, that will be the number arrived. Okay. How many parts arrived at the facility or the manufacturing factory. Okay. So, that is the number arrived part. Then number processed. Okay. So, how many parts are converted to finished goods for delivery to the customer. So, that is the number of parts that are processed. So, how many parts are converted to finished goods? Okay, that gives you the number processed. Then utilization. Okay, how much of the time a specific resource, let us call it as a machine, okay. Specific resource, a machine is doing productive work, okay. That is what is the utilization aspect of it. Then number in the queue, okay. It measures how many parts are waiting in a queue to get processed. So, how many parts are waiting in a queue before a machine, in front of a machine, so that it can get processed? That will be the number in the queue. Then average processing time, okay. It is how long on an average a particular machine takes to process a part, okay. So, here is an average, or what we call as an estimate, okay. They are all estimates on that regard, right. So, how long does a particular machine takes to process a particular part on an average? That is what we call as the average processing time, okay. Similarly, also maximum processing time, okay. So, this is the what is the maximum value of processing time among all individual processing times. Okay. So, what we are doing here is that you are measuring, okay, you have individual, if you are producing 100 parts, each one of the part will have an individual processing time, and from that individual processing time 100, find the maximum value, and that will be the maximum processing time. So, these kind of variables that I mentioned to you, the number in system, number arrived, number processed, all those kind of things are quietly common when you are studying any of the systems in the for simulation, and these gives you approximate idea of what is the final performance of system when the simulation is completed or when the simulation is running as time progresses. Okay. The next variable we are going to talk about is the lagged output variables. Okay. The lagged output variables are a unique category of variables in the case of simulation, because these lagged output variables can carry these variable can carry the system state information from one time period to another. Okay. Remember that we draw the graph of the behavior of the system, and on x axis we had time, and y axis there were different factors that we are measuring, and we were seeing that the behavior of the system was doing something like this and this kind of stuff. Okay. So, the time dependent behavior of the system, okay, when you carry that information of the time dependent behavior from one time instance to another, from this particular time instance to this, to this, to this. So, these time instances, the way you transfer this information to these time instances is what we call as the lagged output variables. Okay. So, they carry system state information. Remember, state means the particular status of the system at a given time. This time is a simulation time, not the real time. Okay. So, then that is that system state that gets transferred from one time period, one a particular time period to another, is what is the job of the lagged output variable. Okay. These variables these variables are also known as serially correlated variables. Okay. These variables are correlated purely because of one reason, because they carry time dependent data. Okay. So, the data at time t is dependent on t minus 1, the previous time period, or t minus whatever you want to call it. So, the t and t minus 1, they are related or they are dependent on each other, hence it becomes correlated. So, it is called serially correlated because as time progresses you will see t minus 1, t, t plus 1, t plus 2, etc. So, they are serially, these values are correlated. So, hence it is called as a serially correlated variables, right. Also, it should also be noted that these variables sometimes act as input variables where the state of the system at a specific time instant is an input to the system at another time period. Okay. So, the variables, sometimes these variables they act as an input variable, because the state of the system at a specific time instant is an input to the system at the other time period. So, let me give you a small example. Let us say that you have a milling machine and a drilling machine. Okay. So, each one of the machines have its own queue and parts arrive in the milling machine and the drilling machine. So, they come to the mill, from there they come to this queue, from this queue they come to the drill and then they leave. Okay. So, here is the arrival. Okay. So, the parts arrive, then from there they, if the machine, so here the machine is free, then they go directly to the mill. If not, the machine is free, it will join the queue. This is mill queue, this is the drill queue. Okay. And then once the milling is over, it will look whether the drill is free, and if it is free it will go directly, otherwise it will join the queue. Okay. And let us assume that here is a drill bit or drill bits. Okay. So, here is like a stock area, you are stocking drill bits here, and here you have what you call as a mill heads. Okay. So, this is another stock area where the milling heads are stocked here. So, depending upon the number of parts that are processed, the drill and mill bits will come here, which will result in changing the milling and the drilling heads depending upon the tool wear. So, then this is dependent on number of parts or how long the bit is used. How long the drill bit has been used is one important question, and if the particular time reaches, then the drilling machine will stop and will say send me a new drill bit. Okay. And then only the process will remove. So, the state of the number of drill bit, how many drill bit are there at a particular time, okay, number of bits at time t is an input to this particular system. So, hence we can say that the lagged output variables maintain system state information info across multiple time instances. So, they keep track of what is happening in the system over a good period of time, so that you can actually get the right information that is necessary. Then we talk about what we call as the external variables. Okay. These variables, they are used to model the extrinsic factors. Okay. Extrinsic factors means factors that are outside the boundary of the system. So, as I have drawn earlier is that if you think about this as a system, so not a system, this as a what we call as environment, and let us assume that this is the system we are studying. Okay. This is the system of interest, then this part is the boundary. Okay. So, factors that are outside. So, if there is a particular factor f1 right here, then that factor is this is a external factor. This is a pictorial representation of the same. Okay. So, the influence of the external factor, how this external factor will influence the behavior of the system, is being studied using external variables. Okay. So, these external variables can significantly influence the system or vice versa. So, what we are saying is that it can either significantly influence the system or it might not influence the system at all. Both of them is possible. Okay. They are also known as environmental variables or exogenous variables or uncontrollable variables. Okay. All these, the environmental variables, exogenous variables or uncontrollable variables, they are all one and the same. They all refer to what we call as external variables. So, an example of this is the dearness allowance, popularly known as DA. Okay, dearness allowance is set by government. Okay, influences financial of organizations. You have no control over what is the DA that the government is going to set. The government will set the DA according to many conditions and its own whims and fancies. And once the DA is set, then you have to use that DA and give the salary to the people who are working in your organization. So, hence that is a factor that you have absolutely no control over. It is an environmental factor, but it have a significant impact on the way your business operates. Whereas, the other time the government might give the minimum support price of rice, and the minimum support price of rice might not be that important to the automotive industry for which rice is not a raw material. So, then the impact of the minimum support price of rice on the automotive industry will then be quite low compared to the dearness allowance rate that is set by the government, which directly influence the employee salary, right. Also, typically these variables, these external variables are used to model interactions of the system with that of the environment, Okay. So, if you want to model the interaction of the system with respect to the environment, then what you need to do is you need to use the external variables to model that interaction. Now, from there you will get into what we call as the policy variables. Okay. Policy variables are interesting because ideally speaking, these are the factors, these model. Okay. So, policy variables are used to model or represent factors that can be controlled by the management. Whatever the factors that are controllable by the management, whatever the management can control, that factors are basically modeled by policy variables. Most popularly known as decision variables or controllable variables. Remember that external variables were uncontrollable, whereas in this particular case we are talking about controllable variables or decision variables. We call it as a decision variable purely because this can be controlled by you. Okay. Your decisions dependent on controlling it. So, let us say that for example, okay, a lathe spindle can rotate at RPMs varying from 0 to let us say 1500, then at what RPM the lathe should operate? That is a decision variable for you. Should it operate at 200 RPM? Should it operate at 500 RPM? Should it operate at 1000 RPM? That question, that decision you have to take, because the speed of the lathe is controllable. This speed can be controlled by you, hence that is the controllable variable. Okay. And during simulation, these variables are systematically investigated to determine the ideal set of policies to obtain effective system behavior. Okay. So, assume that, let us take the example of the lathe again. In the lathe you can decide what the things that you can decide is RPM is varying between 0 to 1500. Okay. Then you have the depth of cut. Okay. It can vary from let us say 0 to 10 mm, and then the feed rate, let us say it varies from 0 to let us say 5 mm per second, something like this. Okay. I am just putting random values, and then tool bit. Okay. You can say carbon steel and let us say diamond for the time being. Okay. So, then you can decide a particular value. Okay. So, this will be one particular value, a V1, this will be V2, V3, and then you put another value V4, and you can have many such combinations of this. Okay. you have this is one particular combination. Then look at different such combinations and then decide which is the best. Okay. So, by doing this, what you are going to do is you are going to basically find out the ideal set of policies that you can actually use to decide the behavior of the system. Okay. So, now we are back to the again looking forward into the variables. The next type of variable that we are going to talk about is the random variables. Okay. What it is used is, it is used to capture the probabilistic nature or randomness in the system. Okay. So, or what you are trying to do, it is each outcome or state of the system can occur with a specific probability. Okay. So, if I say that, so for example, if you take a drilling machine and your part has been, okay, you are manufacturing, you are drilling 2 holes. Okay, if that is what you are trying to do, and then let us say, if I say that the drilling time, the time to drill 2 holes vary uniformly between 10 to 18 minutes. If I say that, then what I am saying is, I can represent a system something like this. This is 0, this is 10, this is 20, like this, this is your time, and here is the probabilistic nature. So, then up to 18, we will say all values between this are equally likely, because it is uniformly distributed. If I say instead of uniform, if I say normally distributed, then it will be something like this. You will have, the variation like this, and you will probably say this is between 10 and 18 or something like this, however you want to draw it. Okay. So, this will give you the bell shaped curve. Okay. So, this probabilistic nature, or what we call as the probability associated with the behavior of the system, okay, is typically captured using with the help of random variables. Okay. These variables are used to introduce necessary realism to the simulation model to mimic reality. Okay. So, these variables, variables means these random variables, they are typically used, or people use these random variables to introduce necessary realism, okay, or necessary what you call as the randomness into the system, so that you can model reality. Yeah. And a reality systems are random in nature, or the behavior of the system has a probability associated with it. This is not a completely true statement, but you can say that the behavior of the system has a probability associated with it. So, that to mimic that probability, that probabilistic behavior, or that uncertainty in the expected output is created using such a system. Okay. These variables are also known as stochastic variables. Okay. So, when I say we are talking about stochastic variables, then the main aspect is this, that we are talking about random variables. Okay. And usually in simulation models, these variables are found to be associated with various sampling distributions. So, what we are saying here is that various sampling distributions are used to introduce. So, these sampling distributions introduce randomness. This is like let us make it as a broad statement. We will make it more exact as we progress later down the road in this case. Okay. So, as I said earlier, the random variables capture the randomness in the system, and this is done to mimic the reality or realistic behavior of the system. And in reality, that the systems have some stochasticity, or the behavior of the system is dependent upon some probability, and these stochastic variables are used to actually introduce the randomness or the variation in the system, which is associated with that of the sampling distributions. Now, let us get into what we call as the last set of variables, which we call as the deterministic variables. So, the deterministic variables, they are used in probabilistic simulation models. Okay. So, deterministic variable in probability, I will explain that to you. You use them to model situations whose contributed variation to the system is quite small. Okay. So, if a particular part of the system, okay, or let us call it a subsystem, if a particular part of the system or a subsystem is not contributing much, or let us call it as negligible, okay, and much to the overall system variability. I am not talking about uncertainty, now I am talking about variability. Okay. We will study what it is, system variability, in the following classes. To the overall system variability, if a particular part or a subsystem does not contribute much to the system variability, then deterministic variables are used to model such behaviors. So, the deterministic variables are used in situations where the subsystem does not contribute much, or it is a negligible contribution to the overall system variability. Okay. So, these are usually used to model low variable things like machine lifetime, okay, scrap rate, etc. So, these are the things that does not contribute much to the variability, the machine lifetime, scrap rates, all these kind of things are much less in the case of a manufacturing system. So, hence you will use a deterministic value to pretty much model such behavioral system. Okay. But the modeler should pay extreme caution or care should be taken, okay, very careful. When deterministic variables are mixed or intermingled with random or stochastic variables. Okay. So, if you are a modeler and you are trying to mix, okay, deterministic variables are getting mixed or intermingled with stochastic variable, then use extreme caution or be very careful, because many modeling errors happen due to this. Okay. So, my suggestion in this regard is that when you are modeling deterministic variables, you are mixing them with the stochastic variables, then please ensure that you pay extreme caution. All right. With this, we come to the conclusion of this particular topic about the basic type of the approaches, the difference between analytic and numerical approach, and as well as different type of variables that are used in the modeling or used in the simulation studies. And from based on this, now we will get into simulation like methods, and the next lecture we will look into Monte Carlo and see how Monte Carlo works, and from there then we will get into an overview of probability and statistics that is necessary for our simulation course, and then we will move towards studying various simulation software and other stuff. So, for this particular class, I will recommend you guys to go through the lecture notes and start studying, getting more information about this. Additional reading materials will be provided, and please read your textbook in the meantime. Thank you very much.